Namaste student. Today you learn about what is the different law of chemical combinations. Okay, every chemical reaction is based on 5 laws. Before you learn about the 5 laws, first you know the definition for chemical reactions. Okay, each and every molecules or atoms react together to form a new product, and such process is known as chemical reactions. Okay, the chemical reaction is based on 5 laws, that means law of conservation of mass, and law of definite proportions, and law of multiple proportion, and law of reciprocal proportion, and Gay-Lussac law of combining volume. Okay, in this video you can learn about these 3 laws.
Now it's time to learn about the 5 important laws that allows us to understand the way in which the chemical species react in a chemical reactions. So let's understand the different laws of chemical combination. Now let's understand the laws of chemical combination, the laws which govern the chemical combinations. Okay, so let's discuss about it. So what are all the laws of chemical combination? We have 5 laws of chemical combination we have. One is law of conservation of mass, law of definite proportions, law of multiple proportions, law of reciprocal proportions, and Gay-Lussac's law of combining volumes. So 5 laws we are going to learn about these 5 laws. So in this part I will discuss about the first 3 laws, and the last 2 laws I will discuss in the next part. Okay. So first let's see what is the law of conservation of mass. Law of conservation of mass says that the total mass of the product remains equal to the total mass of the reactants. Okay. So which depends upon, like, the mass is neither created nor destroyed. Okay. So since mass is neither created nor destroyed, the total mass of the products, they should always be equal to the total mass of the reactants. Okay. So if you take the reactants, so if you take a chemical reaction where hydrogen and chlorine reacting together and they are forming hydrogen chloride, so here calculate the total mass of the reactants and total mass of the products, and those two will be equal. So here hydrogen 2 grams, chlorine this is 71 grams, 1 mole we are taking, so we are getting 2 moles, so that is 73 grams we are getting. So the total mass of the reactants is 73 and the total mass of the products is also 73 grams. Okay. So there is no any change of mass during the reaction. The total mass of the reactants are equal to products. So this law is used to balance any chemical reaction. If you take this chemical reaction, the methane reacts with oxygen and is forming carbon dioxide and water. Here this reaction is balanced according to the law of conservation of mass. Okay. So what will do is, whatever may the number of atoms of one particular type on the left hand side, they should be equal to the number of atoms of that type in the right hand side. Okay. So 1 carbon we have on left hand side, so in the reactants, so 1 carbon should also there in the products. Okay. So in this way we balance any chemical reaction. That is based upon the law of conservation of mass. Okay. So now let's discuss about the second law. The second is the law of definite proportions. The law of definite proportions. So what does this law states? Let's see. A chemical compound always contains the same elements combined together in the same proportion of mass. So if you take any particular compound, irrespective of the source from which it is obtained, it always contains the same set of elements in the same ratio of their masses. Okay. So let's take an example for that to understand this law. See, if I take water, so this is ice water, whose chemical composition is H2O. It contains H2O molecules. So here the 2 grams of hydrogen is reacted with 16 grams of oxygen. So we have the 1:8. This is the mass ratio of hydrogen and oxygen in ice water. Okay. So here hydrogen and oxygen are combined in this ratio of their mass. So if you take the river water, it is also have the same elements, hydrogen and oxygen, which are combined in the same ratio of the mass. Okay. So similarly, if you see in seawater also going to contain hydrogen and oxygen, which are combined in the same ratio. Okay. So what it says that if you see the water, irrespective of the source from where you are seeing, here you are seeing ice water, this is river water, this is sea water, but the compound, that water, the chemical compound water, is always containing the same elements, hydrogen and oxygen, which are combined in the same proportion of mass, that is 1 gram hydrogen and 8 grams oxygen we have. So this ratio is always fixed and the elements are also fixed. Okay. So that's why this law is known as law of definite proportions. Okay. So let's go to the third one, that is the law of multiple proportions. This law states that when the two elements they combine to form two or more than two different compounds, then the different masses of one element which combines with the fixed mass of the other element bear a simple ratio to one another. Okay. So let's understand this statement by taking an example. Okay. So if you see, let's take carbon monoxide. In carbon monoxide, we have two elements, one is carbon and other is oxygen. So these two elements, they are forming two compounds. So here they are forming two compounds. So some elements they form more than two compounds. Okay. So the different masses of one element which combine with the fixed mass of other element. So here we have carbon monoxide, one carbon we have and one oxygen, and we have one carbon we have and two oxygens we have, right? So here what is that element that has a different mass? Here in this case oxygen, right? Here the same mass, the carbon, only one atom is reacted in both the cases. So this is the fixed mass of element, that is carbon. The different mass of one element, that is oxygen. Okay, it's a different masses. So here it is, oxygen is 16 grams and here it is 32 grams, right? So the different masses of one element which is combining with the fixed mass of the other element bear a simple ratio to one another. So here this is the fixed mass and this different mass, there is just simply the base a simple ratio to one another. Okay. So here 1632, which is a 1632 is simply 2 times 16, right? So which is a simple ratio. Okay. So this is the law of multiple proportions. Another example you can see NO and NO2. We have, this is fixed mass of one element and this is the different mass of other element, that is oxygen, and it is one atom, that is 16 grams, and here it is two atoms, 32 grams. So in this case, see, this is the different masses of one element which is combining with the same mass of this element. Okay, and these two ratios, they simply the simple ratio to one another. Okay, so this is 16 and this is 32, which bears a simple ratio to one another. Okay, so this is about the law of multiple proportions. So in this part we discussed about three laws. One is law of conservation of mass, other is law of definite proportion, and other is the law of multiple proportions. Okay, we learn with the examples. Now we will see a video demonstration on the three laws of chemical combination. One is law of conservation of mass, other is law of constant proportion, another is law of multiple proportion. So to understand it better, let's see a video presentation. So first thing we are going to learn about the law of conservation of mass. Law of conservation of mass. So this law is given by Antoine Laurent Lavoisier. Antoine Laurent Lavoisier, this law of conservation of mass is given by. So which says that in a chemical reaction, so this is the mass of the products is equals to the mass of the reactants which are involved. The mass of those things are equal. So this law states that mass cannot be neither created nor destroyed in a chemical reactions. It cannot be created or it cannot be destroyed, and mass of the reactants, the total mass of the reactants equals to the total mass of the products. So to understand this law, let's take an example. In this example will take magnesium is reacting with oxygen and it is forming magnesium oxide. This is the example that we are taking. So here if you see, the two magnesium atoms will react with one oxygen molecule and it forms 2 formula units of magnesium oxide. Okay. So, like this is 2 moles will combine with 1 mole, it will give you 2 moles, right. So, let us see about this reaction. So, here the 1 mole of magnesium is equals to 24 grams, the 1 mole of magnesium. So, if you take 2 moles, it is 48 grams. So, similarly, if you take oxygen, if you take these many particles of oxygen, that is Avogadro number of molecules of hydrogen, its molar mass is equals to 32 grams. We are taking 1 mole of oxygen. So, we are taking 2 moles of magnesium and 1 mole of oxygen. The total mass is equals to 48 plus 32, which is equal to 80. 80 is the mass of the reactants. So, similarly, we can also see the mass of the products, that is the product is MgO. The 1 mole of NgO weighs 40 grams, but you have 2 moles. So, total mass of the products is equals to 40 plus 40, that is 80. So, the mass of the reactants is 80 and the mass of the products is also equals to 80. So, we can say that the total mass of the reactants is equals to the total mass of the products. So, similarly, here you can see the number of magnesium atoms on the left hand side, equals on the right hand side. Similarly, the number of oxygens on the left hand side equal to right hand side. So, this is also according to the law of conservation of mass, which says that mass cannot be created, it cannot be destroyed. The total mass of the reactants is always equal to the total mass of the products in any chemical reaction. Okay. Let us move on. Now, let us discuss about the law of constant proportion. So, this law of constant proportion is given by Joseph Louis Proust and is also known as law of definite proportions, which says that in a chemical compound the elements are always present in different proportion by mass, in definite proportion by mass, that is fixed proportion by mass. So, if you take water H2O, which is formed by the combination of oxygen and hydrogen, if you take the water that is collected from well or spring or river, this water, irrespective of the source, it contains the same elements which are combined in the same ratio. So, let us take this example. The water, if you see water which is containing H2O molecules. So, if you take one particular H2O molecule, it is containing 2 hydrogen atoms and oxygen is 1 oxygen atom it is containing. So, the mass of 2 hydrogen atoms is 2 grams and the mass of 1 oxygen atom is 16 grams. So, you can see the mass of 2 hydrogens is equals to 2 grams, the relative atomic mass, and it is 16 grams. So, 2 grams of hydrogen is combined with the 16 grams of oxygen and it is formed 18 grams of water. Okay. So, the 2 plus 16, this is the ratio in which the hydrogen and oxygen are combined with each other, that is 2 by 16, that is 1:8. So, this is the ratio of hydrogen to oxygen in water, which is fixed irrespective of the source from which you collected the water. So, this is known as the law of constant proportion. Now, let us discuss about the law of multiple proportions. So, this law is given by John Dalton. So, here if you see what this law says that if the two elements, if they are combining and they are forming more than one compound, then the ratio of the elements which combine with the fixed mass of the other element will be a simple ratio to each other. So, here if you see, the one atom is combining with one atom and 2 atoms of A is combining with 1 atom of B and 3 atoms of A 1 and 4 atoms of A is combining with 1 atom of B. So, in all these 4 we have only 1 atom of B. That means the amount of B present is same, fixed amount of B is present, but A is only varying. So, if you see this ratio, here 1 atom of A, 1 atom of B, the ratio is 1:1. Here the ratio is what? B is to A is 1:2, 1:3, 1:4, all are simple ratios. That means the ratio of the oxygen, like not only oxygen, like the different mass of the elements that combined with the fixed mass of the element will be in a simple ratio. So, to understand it further, let us take one more example. Here the high concentration oxygen combines with carbon and it forms carbon dioxide. So, if oxygen is taken in less concentration, it forms carbon monoxide. So, we have carbon monoxide. So, in carbon monoxide, 12 parts by mass of carbon is combining with the 16 parts by mass of oxygen. So, in CO2, the 12% by mass of carbon is combining with the 32 parts by mass of oxygen. So the ratio of mass of oxygen in these two compounds is 16:32, right? That is the simple ratio 1:2, the ratio of oxygen in both the cases. So if you say in these two compounds, CO and oxygen, the mass of the carbon is fixed, that is 12, and oxygen mass is varying, that is in CO it is 16, in CO2 it is 32. So the ratio of the oxygen in these two compounds is simple, that is equals to 16:32, that is 1:2, which is a simple ratio. So this is the law of multiple proportions. This is the law of multiple proportion. An example, we have taken the carbon monoxide and carbon dioxide. Okay, so this is all about the law of conservation of mass, the law of definite proportions, and law of multiple proportions. While
Okay children, I hope you understand law of chemical combination. In this video, you learn about law of conservation of mass, law of definite proportions, and also law of multiple proportions. Law of conservation of mass is nothing but the mass of the reactant is equal to mass of the product during a chemical reaction. And law of definite proportions, if a molecule is made up of a different elements or the same element, the ratio will be a simple. Obtained from this molecule is same, either it obtained from different source or not. Okay, for example, water obtained in ponds, river, etc. But its molecular formula H2O and its mass is 80 gram and its ratio is 12:1. Okay, and law of multiple proportion, if a definite mass of the element combined with two different mass of the other element, the mass will be simple ratio. Already example for this law is seen in this video.